Good afternoon, class. So till now we have done MS Window, we have done DOS. Now your next in new syllabus next we will learn about data representation. So data in computers, we talk in human language, whatever it is, maybe Bengali, English, Hindi, Tamil or French or Spanish, whatever it is, these are all human language. Okay, but computer does not understand human language. They understand machine language. So in whatever form we communicate, for computer they change it into from human language to machine language, and then they will be able to operate or process it as needed. Now, computer there are three types of systems that are used for converting a machine language into converting human language into machine language. These are number system. Second is bit and bytes, and third is text code. Okay, text encode. So so I have given the notes of all these things. I will give the notes of all these things to you, where we will also talk about what is binary, what is octal, what is decimal, and what is hexadecimal. Okay. So just for the sake of to start the next topic, that is binary arithmetic, that is simple addition, subtraction, plus complement. Let me just discuss what is binary, what is octal, what is decimal, and what is hexadecimal. I will give the notes also. Okay, for that. So what is binary? Binary means it only considers two numbers. Base is, first of all, the base is 2, and it only considers two numbers, that is 0 and 1. Okay, it only considers 0 and 1. There is no other number that they consider in this binary system. So what is 0? 0 means 0. Actually, 0 and 1 are not numbers. These are signals. Right? 0 means off, 1 means on. Okay. Similarly, octal base is 8, and it considers number from 0, 1, 2, 3, 4, 5, 6, 7. Okay. These are the 8 numbers that they consider in their number system. Similarly, decimal base is 10, and numbers they consider is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means this is nothing but it works like our number system that we understand, right? Hexadecimal base is 16, and it considers number from 0 to 9, and then A, B, C, D, comma E and F. Okay. We will understand the conversion from binary to decimal, decimal to hexadecimal, hexadecimal to octal. We will understand all these things in the next class. For now, just understand this one. Now, in your syllabus, it's saying binary arithmetic, that is simple add and subtraction. Okay. So, for that, you need to understand this, that there are some rules for binary addition and binary multiplication. So first we will understand, binary subtraction. So first we will understand binary addition rules. So I have already discussed that binary numbers are nothing but 0 and 1. 0 means off, 1 means on. Okay. So first rule 1 is 0 plus 0 is equals to 0. Okay. Rule 2 is 0 plus 1 equals to 1. Okay. Rule 3 is 1 plus 0 is equals to 1, and rule 4 is 1 plus 1 is equals to 0 with a carry 1. Okay, so it's 0 with a carry 1. Now, how to do this? Okay, let's take an example. Suppose we want to add, say 0 1 0 1 with 1 0 1 1. Suppose this is what we want to do. So how we will do it? Okay, let's see how we will do it. Let me just increase the size a little bit. So now our number is 0 1 0 1. We want to add with 1 0 1 1. Okay, so we want to add it. So what is 1 plus 1? What is 1 plus 1? I have already said 1 plus 1 is 0 with a carry 1. Okay. Now when I say carry 1, that means 1 plus 1 0. This carry 1 will come here. This carry 1 will come here. Right? So now again, what we have? 1 plus 1. So what we have for 1 plus 1? 1 plus 1 is again 0. 1 plus 1 is again 0. Okay. Again we have a carry 1. So this carry is over here. Okay. Now again 1 plus 1 is 0. Again my 1 plus 1 is 0. Okay. And again it will have a carry 1. It will have a carry 1. Now again we have 1 plus 1. 1 plus 1. So 1 plus 1 is again 0. And because it has a carry, it will have 1 plus 0, because here we don't have anything, right? So it ends here. So it will have 1. So 0 1 0 1 plus 1 0 1 1 is 1 0 0 0 0. Okay. Now if we take a, say, simpler one like say 0 0 1 1. Sorry, let's take it. Plus 1 0 0 0. Just for the sake of simplification, I am giving this example. Okay, let's see what will happen here. So 1 plus 0 is 1. 1 plus 0 is again 1. Okay. Then we have 0 plus 0 is 0. And 0 plus 1 is 1. So what we have for 0 0 1 1 plus 1 0 0 0, we have 1 0 1 1. Okay. This are nothing but carry forwards. Okay, so this is binary addition. Now if we talk about binary subtraction. Binary subtraction rules. So first, rule 1 is 0 minus 0 is equals to 0. Okay. Rule 2 is 1 minus 0 is equals to 1. Okay. Rule 3, this is very important, that is 0 minus 1 is equals to 1 with a borrow 1. Okay, what does it mean? It means that we are converting, let me write the rule 4, then I will discuss what it means. Rule 4 is 1 minus 1 is equals to 0. Now what this rule means, 0 minus 1 equals to 1 with a borrow 1. This means, see, if you convert a binary number into decimal number, what is binary number? 0, 1. What is decimal number? The number system that we use, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and in the combination of these numbers we can create like any numbers, 99, 210. Okay, so these are decimal numbers. So if you convert this binary number into decimal number, how, I'm just giving you a very small example how to convert a binary number into decimal number. Suppose you have a number, say 10. So how will you convert this 10? Whenever I write something like this, whenever I write something like this, 2, that means it's a binary number with base 2. So now if I want to convert it into decimal number, how to do it? Okay, so to convert it into decimal number, what we will do is, we will start from last digit. What is my last digit? 0. So 0 into 2 to the power 0. 0 into 2 to the power 0. Okay, plus 1 into 2 to the power 1. Okay, so 0 into 2 to the power 0 plus 1 into 2 to the power, that is how it goes, right? Like for example, this one, it will have 1 into 2 to the power 0 plus 1 into 2 to the power 1 plus 0 into 2 to the power 2 plus 0 into 2 to the power 3. Similarly for here, we will have 0 into 2 to the power 0, 0 into 2 to the power 1, 0 into 2 to the power 2, 0 into 2 to the power 3. So what we will have here, 2 to the power 0 is 1, right? So 0 into 1 is 0. So what we will have here? We will have 1 into 2 to the power 1, 2 to the power 1 is 1, 2 to the power 1 is 2, so 1 into 2 is 2. So what we are getting here, when we are saying this, that 0 minus 1 is 1 with a borrow of 1, that means we are taking 1 0. We are taking 1 0, 1 0 means, here 0, I am adding 1 over here, right? What does it mean? Here we had 0, I am adding 1 here. So 1 0 in binary converts into decimal, gives you 2. So 2 minus 1 is 1. That is why I am getting this. Okay, that is why I am getting this. So now let us take an example and let's see what we get. Suppose we want to subtract say 0 0 1 1 from 1 1 0 0. Suppose this is what we want to do. Now how we will do it? Okay, So what we have? We have 1 1 0 0 minus 0 0 1 1. Okay, that is what we have. Let's see what we get. So 0 0 minus 1 is 1 with a borrow 1, right? Now when we say borrow 1, that means I am borrowing, I should have borrowed it from the previous bit, that is this bit, but here we don't have 1. So from where I will borrow it? I will borrow it from its previous one. So I will borrow 1 from here. Okay, so when we borrow 1 from here, that means 1 comes here. So what we get in the next bit, we have here the borrow is 1, and from where we got it? From the previous one. So 1 minus 1 is 0. Okay, what we have? 1 minus 1 is 0. Okay, now again we have 1 here. Okay, now this 1 was borrowed here. So what it becomes? It becomes 0. Why? Because I have borrowed this one. I have borrowed this one in my previous summation. Sorry, subtraction. In my previous subtraction, like when I was subtracting 0 minus 1, I have borrowed this one. So now what it becomes? It becomes 0. So 0 minus 0 is 0 minus 0 is 0. Okay, 0 minus 0 is 0. Now we have 1 minus 0. So what is 1 minus 0? 1 minus 0 is 1. Okay, 1 minus 0 is 1. Just a minute. So subtracting 1 1 0 0 from 0 0 1 1, what we get? 1 0 0 1. Okay. Now if you have to check whether it is right or wrong, you can actually convert them into binary and you can check. Now what is the binary of 1 1 0 0? Let's see what is the binary of 1 1 0 0. So the binary of 1 1 0 0 will be 1 into 2. I am writing, okay, just a minute. Let me write this one. 1 into 2 plus 0 into 2 plus 0 into 2. Just a minute. The powers I am writing. Give this. 0. Okay, so 1 1 0 0 means 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 0 into 2 to the power 0. That will give you equals to 1 into 8 plus 1 into 2 to the power 2 is 4. Okay, rest 0 into whatever you do is 0, right? So equals to 8 plus 4 is 12. Okay, that is what you get here. Now come here. What is 0 0 1 1? 0 0 1 1 is 0 into 2, whatever it is I will write later. 0 into 2 plus 1 into 2 plus 1 into 2. Now what we have? Again we will write same things like 0 1, 2, 3. So what we get here? 0 equals that is equals to 0 into whatever it is 0. So 2 to the power 1 is 2. So 1 into 2 plus 1 into 1. Why? Because 2 to the power 0 is 1, right? So that will give you 3. So 12 minus 3. What is 12 minus 3? What is 12 minus 3? 12 minus 3 is equals to 9. Let's see if I have 9 here or not. Okay. So, again 1 into 2 to the power 3. What is 1 into 2 to the power 3? 1 into 2 to the power 3 is 8. Plus 0, 0, leave it. 1 into 2 to the power 0 is 1. So, 8 plus 1 is 9. So, 1, 0, 0, 0, 1, 0, 0, 1 is equals to 9. So, that is what you are getting. 12 minus 3 is 9. That is what you are getting here. Okay. In the next class, we will discuss conversion. Okay. Right now, I told you a little bit, but we will discuss with more example how to convert binary to decimal, then decimal to binary. Okay. That we will discuss. Thank you, class.